So as architects or designers, I think the one thing about 3D printing that really excites us is its design capabilities. It's not just because right now it's using traditional materials. So what we can do with the machine is what's exciting, what's different, at least to me. So I think in the 80s or 90s, Gehry Technologies, Frank Gehry's company, developed this new software called CATIA because they had such complex projects. There was no software out there that could decipher it and turn all these complex projects and facades into realistic drawings. And so they had to develop their new software.
Yeah, architects like Zaha Hadid push what is called parametric design.
So what is parametric design? We did it, all of us did it in school.
It's interesting. Whenever we got into architecture school, I'm sure it would have been very different doing architecture 10 years earlier. Same as the way it is now. I'm sure it's very different. But this parametric design, what the software could do, programming to help develop your building design, really started to evolve into something. Like before, it was just simple, straight, clean lines, everything.
It was dictated by the designer.
Or dictated by the software, like the capabilities of the software. Like you said with Gehry, they had to come up with their own software to be able to handle these complex shapes. Well, with parametric design, you're able to explore new shapes that you didn't know were possible by inputting this information into code and allowing that to not design your building, but give you ideas.
So it's a really good definition. It's exactly what you said. Parametric design is a design method where features are shaped according to algorithmic processes, in contrast to being designed directly. So you create a formula, and then you allow the formula to run and create these shapes that you hadn't thought of or you would have to manually design.
Unfortunately, I'm sure it's different now, but in architecture school, for us, parametric modeling or parametric design was so new that we were literally just exploring what it could do. There wasn't much reason behind it. And I think hopefully that's what we're getting to now, is where this parametric design is used with logic and reasoning, and it helps us come up with more efficient shapes.
It's not form for the sake of form. For example, we're not just designing a funky wall for the sake of it. We're using parametric design to create a wall that uses 50% less material or is far more energy efficient or resource efficient. There's a strong underlying reason to that wall.
So that's similar to the bridge that Volker and his team designed, where they actually took out as much extraneous material as possible.
I think they call it a topology optimized bridge.
That beckons back to modernist architects like my favorite, Le Corbusier, who would keep everything minimal and cut it down to the essence, no extra ornament. And you're seeing that used in parametric design.